Welcome to the opening sessions of the Past 7 again. You guys great to be back here again? Yeah, it's awesome. Yeah. So that was a fun keynote. Hope you enjoyed that. We had fun doing it. Let's do a little more technical stuff here today. I'm Bob Ward, a principal architect here at Microsoft. So excited to be joined by Ajay. Ajay, tell everybody who you are and what you do and how long you've been here.
Yeah, not as long as you, but I've been here for 24 years, all with SQL. I lead the product management for SQL Server and our hybrid technologies with Arc. And looking forward to talking and meeting a lot of you this week and sharing some of the work we've been doing as a team.
Awesome.
Yeah.
So you may have heard of this product called SQL Server 2022. We launched last year at this conference. And I know I spent a lot of time, almost the last 2 years, talking about SQL Server 2022. So as I was going into a conference last year called BITS, SQL BITS, you may have heard of that one, I thought, what could I do different that I've not presented on 2022? So being here 30 years, you know people in the product team itself. I'm in the engineering team. I just know a lot of people. And I know who to talk to for folks that write things that could be called hidden gems. So I started reaching out to the team going, hey, I did a lot of talking about 2022, but what is stuff that didn't really make the headlines? What is hidden? What is hidden gems? In fact, I don't know if you recognize this diamond here in the front. This is the Hope Diamond at the Smithsonian Institution. You may recognize it as the famous diamond on the movie Titanic. So to me, it kind of reflected like, what are those things that people might know and love, especially what I call SQL heads, that just didn't make the marketing materials. And that's what the premise is of this presentation. Quick logistics. You're going to want the deck. You're going to want the demos. Great news for you. ak.ms, Bob Ward MS. The deck's already out there. And the demos are recorded, all built into the deck. And if you want to like take a nap on a Sunday and unmute them, you can hear me talking through the demos as well. So you have everything you need. You can kind of sit back, relax, and enjoy it. I'll put that website up again as we're done. We also have other resources for you about 2022 as well that you might enjoy to use. We have 75 minutes. We normally only get an hour. So we're going to go through and make sure we really explain everything, but we want your questions. So we'll stop periodically to see if you have questions. Plus, I guess lunch is right after this. We'll actually be here available to you until everybody wants to leave to answer your questions after the session. But it's a big room. So if you're in the back and you have a question, you might need to stand up and kind of speak loudly so we can hear it. So let's tell you how we're going to organize this session today. We're going to talk about some X events, some things you might not be aware of, some things we put into the product that we believe can help you, specifically in troubleshooting some interesting problems. Ajay's going to talk about scalability. We have some fun stuff to show you there. I will talk about some availability, things we've done in SQL 2022. Fun story with something called Purvey's List, which Ajay will be talking about. And then we'll just show you a very interesting scenario that you can consider how to archive cold data into a data lake to finish off the session. Sounds interesting? Sounds like some things maybe you've not heard of before. So let's start it off. Let's talk about extended events. I know it's a very popular tracing tool. It's been certainly something for me back in support, now in engineering, very helpful to work with customers. There are some events that you may not know that we put into the product. The first two we're going to talk about specifically in detail about why we did it, how you can use it. But look at this one, plan not cached. That's interesting. You can actually go on your server and just light this up and say, hey, when are plans not getting cached? And you can actually find out why. And that's no cost to that. Or maybe spills for TempDB, or even situations where parameter-sensitive plan optimization is not firing correctly. So X-Event and anyone you see on here is a very helpful tool that is zero cost to you. Turn it on your server, turn it on your test environment, and start using this technology to make you better and more efficient. Let's talk about the first one, anti-pattern query. I've seen a lot of definitions of this. For me, it means this, a query written or designed that prevents it from executing to your expected performance. And you're like, what are you talking about? So let's look at a scenario. You have a table with some columns in here, and it turns out you have an ID. That's an nvarchar 10. So you go create an index on this thing. Like, no problem. I'm going to create an index. I'm going to be seeking on this. I want it super fast. And then you go create a procedure to abstract people searching on this. Pass in an ID, go select from the table, compare it to the column. Everything's great. And on a slow amount of data, it may appear that it is great. But as you may or may not know, if you compare this integer parameter to this nvarchar parameter, we cannot use that index. We convert it. It works great. You get results. But surprisingly to you, we would do a scan in this case. Again, for a very small table, who cares? You get a huge table. All of a sudden now, you have unexpected performance, even though you thought you wrote a correct query. Great example of an anti-pattern query. There are other examples. In fact, we have a blog here we posted about other scenarios that you may write that end up in these unpredictable performance situations. So I was talking to folks in the product team. I'm like, is there anything we can do to detect these when somebody's running a workload so they don't have to go look at all the different queries and figure out, well, this was not using an index, it must be an anti-pattern query. Like, is there something we could do inside the engine? Turns out there is. There's an X event called query anti-pattern to detect some of these, and you see those with the asterisks listed, including the one I just showed you. Hey, man, if you're not going to do a session here, you can't do demos, what are you doing here, right? So let's see it in action. OK, so what I've got here is I created that exact same scenario I just described. I've created a stored procedure to go get it, and notice it fired right away. Now let's go behind the scenes and see why it fired. Well, I can tell by the type of what anti-pattern it is. It's an implicit conversion preventing an index seek. So, OK, what does the plan look like? Well, I've got that in the X event. That's beautiful. So let me go get the plan handle, describe it, look at it. Sure enough, it's doing a table scan. So now I know already, without doing any debugging and just putting this event on, I've got an anti-pattern query that's causing a performance problem potentially for me. And it tells me as well in the plan that I've got an implicit conversion causing the problem. This is great. So what do I do to fix it? Well, first of all, I can tell by looking at the proc of this conversion problem. I can see here that's an ID comparing, and look over here, comparing to my n varchar. Well, as it turns out in my business, I need that n varchar to be the key. So what is the solution? It's pretty simple. Go alter the procedure. Go in here and say, hey, just go change this thing. And I love that create or alter proc option. Just go change this to n varchar. Recompile this thing and run it again and see if it's fixed. So let's go do that. We'll execute it. And we'll go back and run it again and see if the plan's back to where we need it to be. So let's run this. Go back here. We'll get rid of that, of the plan we had earlier. Run the query again. And this time we'll just go look at the plan. And we'll go up. And sure enough, we got an index seek. You think about what it would take you in your dev or production environment to go figure out that problem. What's going to take is somebody complaining about a performance issue. And initially, with a small data set, they wouldn't complain. Like, oh, everything's running great. Then all of a sudden your data grows, and all of a sudden things get slow, and you're like, well, I got to go dig into the plan and everything else. Just by putting on an event like that, you can detect a problem very easily. And you're asking, like, why did you guys do this? You know why we did it? Because we solve problems in the cloud all the time. And so we're trying to go solve some of these problems behind the scenes in the cloud. And so you know what? We're pretty lazy people. We want to go put in an event to help us go make things faster for us. So that's query anti-pattern. Let's look at the second one called query abort. This is a really fun story. I have a colleague of mine named Robert Dorr. Ajay, you know Robert from a long time. Bob is one of those guys behind the scenes, is one of the smartest people in the world. When Bob and I interact, it's like Penny in the Big Bang Theory. Like Bob gets on a whiteboard and starts drawing something, and I'm like, what? What are you talking about? So he contacted me, actually, after we shipped 2022, and he calls me Ward all the time. He said, hey, Ward. He goes, Ward, you didn't put query abort in your session, your decks. Well, what's query abort? And he goes, well, let me explain it to you. So he was trying to solve this problem. When would a query fail when there's no error? And I'm like, what do you mean? If it fails, there's always going to be an error. It's like, no, I mean like an actual server-side error. Well, what do you mean? He said, well, first of all, as you know, Bob, when an application sends a query to SQL Server, we'll take the query, we'll start running the query on a worker thread. And he said, but what if the application decided to cancel the query? Well, that worker thread's handling that query. So what we do is we send what's called an out-of-band attention packet to the engine. Now, our normal I/O completion thread that we have picks that up. And it says, oh, this is an attention packet. But it knows what the attention's for, which session. So we're like, oh, we need to go tell that query to abort. Now, before we had this event, we didn't know what the query was doing because there's something called an attention event that's been around forever. That's only fired after the query finishes, after it's aborted. So Bob wanted to know, when this thing is canceling, what is the query doing? Usually it's two things. Query's running a lot, like some massive join it's doing, or it's blocked. And trying to go figure out exactly at that time, that context is hard to do. So here's what he did. He added this query abort event into the code. There's no cost to this. And when he gets this attention event in this other worker thread, he fires the event. Now, what he does is mark the query aborted. So the query now can either check or be signaled to say, hey, I need to stop running and cancel myself. When it does it, we fire that attention event. So you can see that if we just had the attention event, we wouldn't know what it was actually doing. But because independently we fired the query abort event, we can get context for this. The other scenario would be like a kill. Somebody comes in, a long-running query or a blocking query is happening, it issues the kill, we can get the same type of information. Now, you could tell maybe in the error log that a kill was initiated, but wouldn't you like to know the context of exactly why it happened? Pretty slick. So I said to Bob, how do I figure out this context? He said, well, I don't have it polished yet, but I'm going to use call stacks. Now, everybody in the room is a call stack expert. I know, I get it. And uses the debugger every day. And a lot of times you come to my sessions and want to see the debugger. So I'm not going to show the debugger, but I'll show you something pretty nifty. I'm going to show how you, even though you don't know this call stack concept, can figure out this context. Let's see it in action. So first, if you want to run a stupid query that runs forever, do that. Go join a bunch of system tables like that, right? Go do some silly, because that's all I want to do. I want to run some silly query, and I want to cancel it. So I'm going to cancel the query, and in my X event, notice the query abort and attention fire. So what's this context what am I going to do? First of all, I can see in this abort event the input buffer. That was the query that's running. That's kind of helpful. I probably can tell it's just silly query is the problem, but maybe I don't know that. So first, I'm going to take this call stack from X event and use a tool by our friend Arvin called Call Stack Resolver. You can do this too yourself. It's free. You can download it. It's all possible for you to do. And I'm going to resolve the call stack. Now, what does this look like? This is the call stack of that separate thread that's picking the attention packet up and firing query abort for us. So that's pretty cool. I'm seeing the fact that SQL behind the scenes on a separate thread is doing that. But Bob, you said you're going to give me context of the query. That's the other call stack called the task call stack. So let me go copy that, put it into this tool. Symbols are all available for you to download. It's very easy to do, and see what its context looks like. Now, again, you're not a call stack expert in SQL Server, but can you tell that it's not waiting? You can see at the top of this thing, it's not in some sort of lock scenario. This scan hash you see is a series of joins going on with hash joins. So I can tell already that what was happening here, this query was canceled, most likely because it was a silly query that was running forever. To get that context on your own is pretty hard to do. That's scenario one. Oh, sorry, I'm showing the attention event. So this is what it looks like after the fact. So if you didn't have the query abort event and you went and looked at it, this is the actual thread running the query. You have no context of what it was doing. So just by adding this alone in your system, no cost to you, you can now solve why was a long-running query canceled or timed out. That's the first scenario. Can anybody in the audience think of a second scenario why I'd want to cancel or time out a query? You didn't know I was going to ask you questions, did you? Like so one was running. What about another scenario that's waiting? Like blocked. Yeah, somebody's blocked, right? Let's go see what that looks like. And how can you tell it's blocked? OK, I'm going to do a silly thing here. I'm just going to go create a table, start a transaction, and delete the whole table. And then I'm going to go over here with my SQL command and use a timeout of 2 seconds and say, try to go run a select against this thing. It's going to get blocked, and it's going to do a query timeout. I get the same query abort event for me. Now, I'm not going to show you the original call stack, because you've already seen that for the IO completion worker. I'm going to show you the second call stack. This is the context of the query that was blocked. So let me go look and see what that looks like. And again, Bob, I'm not a call stack debugger like you person expert you are. That's OK. You can do this. Look at the names that are going to show up here. How about lock sleep and the word wait? That's what a typical blocking thread looks like in SQL Server. So now I've got great rich context to tell myself, was I blocked or was I running? So what about the third scenario? What about a kill? What does that look like? This is interesting because I can see the context of the thread that did the kill and actually the canceled scenario. So this is running. Instead of canceling it, some admin comes in and tries to kill the session. Again, remember, we're picking up query abort, so we have this context. Now notice here, the session ID and the other session ID are different. That's because this is the session ID from the kill command. The other session ID is from the query that was running. So I have both session IDs, and I have both context for the call stack. You're going to love the name of this one. I think, what is it called, like nuke spid? Yeah, let's see here. Yeah, colorful names for developers, right? Nuke spid, that's our code that runs the kill command. So I can tell I was doing a kill in this context, and I can go back to the T-SQL call stack, and again, get contacts from the frames, and tell that I was in a long-running scenario. So think about what I showed you. I showed you by turning on a single X event, I can debug query timeouts now. This is so hard for you today to know why. You get complaints from developers that say the web page is having a problem. And then somebody debugs that and says, well, I think we're running queries, and I think it's getting timeouts, but nobody trapped it in the code. And you don't know what's going on. You fire the attention event on SQL Server, you still have no context. What would you do? You start tracing all the queries in the system, which is too expensive. So turning this one thing on can save you valuable time. I think we need to make this experience better for the future. Maybe it would be cool if it just said the word I was blocking or something like that, instead of having a call stack. But still, a very, very handy way and a very advanced way to go in, and a hidden gem in SQL 2022. All right, Ajay, let's hear about some scalability.
Yeah, thanks, Bob. That was two really cool hidden gems to help developers and DBAs troubleshoot really complex application performance issues quicker. So now we'll talk about scalability and how many of you like to make SQL Server run faster than it already does. Right? Every day you're running into problems, and we want to understand what these problems are. And we catch a lot of these problems in Azure SQL on millions of databases. That helps us proactively introduce this. So these are a series of features we have introduced as hidden gems in SQL Server 22, and we'll touch on a brief of them. I'm sure everybody knows and loves TempDB. We'll get to that in a minute. Before that, let me quickly talk about some of the other features. The first one is query store hints. So anytime today when customers write application queries and the expected plan and performance is not same as what they would want, they would introduce what's called plan guides. It takes some effort to create the right plan guide and save it in your SQL Server so that when that query runs, it uses that plan instead of the optimized or generated plan. It works well for some scenarios, but you have to really fine-tune your plan and know what plan guide to use, and it creates a lot of complexity. So this is where we introduce query store hints. Starting with SQL Server 2022, query store is on by default for all newly created databases. Just like in Azure SQL, anytime you have a database that you create, we automatically enable the query store. We are really invested in that feature to make sure that it scales and performs in high volume scenarios, and it does not impact your workload. So we are leveraging query stores to save some of the hints that you would normally use through plan guides, examples like recompile hints or max-stop hint, et cetera, so that this can be used by the query optimizer when your queries come in with that pattern. And the good thing about this is query store is persisted in your database along with the database, so it survives SQL Server restarts or failovers, so that if your instance failed over to another node or you rebooted your machine, your query store still keeps those hints, so the next times these queries run, it'll be able to use the same hints. So the next three categories of improvements are what we call low priority logs. So how many of you run regular administrative tasks like creating indexes, rebuilding indexes, shrink, though we don't recommend running shrink often, update stats, et cetera? A common problem with all these maintenance tasks is they take schema logs, schema modification logs, which is a blocking log. If you're running, let's say, read queries, it can get blocked or be blocking others, and the same thing with other type of log types. So we are introducing these new low priority logs. We had the alter index, which we had introduced in a previous version. So now we're expanding the scenarios. So let's take a look at an example of how this behaves with create index scenario. So in the first example, I have an offline create index. So in this case, let's say a query is running against a table. It takes the necessary logs while it's running. And now if you issue a create index in an offline mode, it requires a schema modification log, which is a non-compatible log with your queries log. So it'll be blocked and it'll wait forever. The hard part is, since our logs is a first in, first out queue mechanism, any queries that come after the create index are just queued behind this. So this creates a very long blocking chain, even though the query which is coming behind the schema modification log may be able to run in parallel with the first query if they are, let's say, read-only queries and they only need shared logs. So this creates a very inconvenient situation, downtime for our applications, and you have to either kill the queries to get out of the situation or wait indefinitely, both of which may not be desirable. So then we introduce the online create index feature, much better than the previous one. Here, let's say a query is running against your table and takes the necessary lock. Now you issue the create index with the online syntax. So this This will basically continue to run. The schema modification lock is taken usually at the very end of the online index when it's switching the old index.
I knew that was going to happen, man.
With the new
It's okay,
index.
just take that off there.
Yep.
It's an old clicker.
So the good news is, in this case, since the schema modification lock is not needed till the end of the index creation, we will let any other queries go through and run in parallel with the original query if they're non-blocking. So this continues to run, but at the very end, when the create index needs to take a schema modification lock, even though it's for a very short duration, it can lead to a blocking operation. So any queries that are running concurrently at the same time on a very busy system, if you have multiple queries coming, they're just queued behind, and it creates a blocking chain. So what are we doing to fix this scenario? Right? Now we are introducing create index with low priority locks. Again, this was the first introduced in SQL Server 2014, I believe, with alter index. And now you can do that with create index, async update stats and shrink like we saw in the previous slide. So how does this work? So let's say the first query is running against the table. Now, if you issue create online index with wait at low priority, this is a new keyword you add to your T-SQL. This will basically put your create index statement in what we call in a low priority queue, not in the regular queue with other queries. So any queries that are coming will just pass through. They will not be blocked by the index statement. And what happens is the index will acquire the schema lock when it finds that window where no query is coming in, and it just takes a few milliseconds to run this final switch. So that happens seamlessly without blocking any queries that are coming or being blocked itself. However, if it's a very, very busy system where the create index at low priority is starved, right? It never gets a chance or window to run the query. You do have a couple of options. You can specify a max duration on how long you want to wait. The queue will be there. The query will wait in the queue there. And at the max duration, if it's still not able to get the schema modification lock, we will basically have an option to abort the query. So that's how this new behavior works.
Ajay, for abort, resumable would help too, right? Though?
Yep. So we also have the resumable index. Yeah. So that's another thing you can do.
You just pick up where you left off.
Yep.
Yeah.
That's a common thing. So especially if you have a maintenance window where you need all these maintenance tasks to complete off business hours, and it has not completed, you can pause and resume.
So I don't see why you wouldn't just use an online resumable with this option on all the time.
That's a great idea.
You know, if it does abort, you just retry it, and you've really made things more available for sure.
It definitely helps those 2 a.m. calls or 5 a.m.
exactly.
calls, and let the system take care of it for you.
Exactly.
Right. So now let's come to the most famous topic. Everybody loves TempDB. There are no issues.
Yeah, nobody cares about
and
TempDB,
everybody
right?
loves TempDB.
Who cares?
And but it's hands-free from 2022. But before I get to that, Bob, you have been here for 30 years,
yes.
as long as SQL Server,
yes.
and you have a lot of stories to tell, and this is one of the cool
when you're
stories.
older, you get to tell stories, right?
Yeah.
But I think the story makes sense in context. You understand why what we've done finally resolves this problem. So, Ajay, in 1998, we have a version of SQL Server called 7.0. And if you remember, anybody remembers those days, we introduced this concept called latching. And we need to because we changed the engine back in 7.0. 7.0 was like a rewrite for SQL Server from the original engine in 4.2 and 6x. So what we did is we had this concept of physically protecting pages with thread concurrency because we have to do more than just do inserts and updates and deletes. We have to change headers and all sorts of stuff. So we need to make sure that we don't have two threads that write to the same page at the same time or read while one's writing, hence this latch concept. So I'm in support in 1998, and I remember vividly about 6 months into the release of 7.0, we started getting a series of phone calls, and it's going to seem very familiar to you. Somebody would say, hey, we're getting latch waits. Well, first of all, David Campbell promised me in 7.0 we would never see latch waits as our customers. We didn't really put that in there so people would see it.
Yeah.
Well, I called David and said, we're seeing it. Customers are calling in and saying, I got a latch wait on DB2, file 1, and some number. And he's like, well, what's the number? And I said, well, it seems like it's on a fixed interval. And he's like, what do you mean by fixed interval? I said, well, it's like a 1, and then it's like a certain number of pages. And he goes, oh, that's because they're getting latch waits on like PFS pages and GAM pages and SGAM pages, which are allocation pages, system pages, that are on fixed intervals in the file. And I'm like, okay, this is a problem. People's like, workloads are down. Like, what do we do? He's like, oh, we know what to do. Create more files. And I'm like, great, how many? Okay, I'm going to shock the audience here if you're younger. Back then, we only had eight CPU machines. He's like, 8. Do 8. Just do the number of CPUs as the number of files. I'm like, is this an I/O thing? Or what? He's saying, no, no, no. If you create multiple files, you're spreading across the latches across the files. And the workers are partitioned now naturally across the system. So this is the origin of the multiple file thing. I'm like, that is great. I mean, that is just so awesome. Terrific, let's go do it. Now, what happened in history since then is that people went crazy. More processors, people started putting like, what, 64 files and 64 CPUs. Ajay, I don't know if you remember, I did a famous talk here at PASS a long time ago called Inside TempDB. Yep. And I did this kind of like, showed people, start with 8, then add 4, but you shouldn't do like 1 per CPU, right?
Correct.
But effectively, the way we started this was doing things by CPU. Now, the story got interesting. So once we did that, do you want to show kind of a little bit of what we did?
Yep. So, I mean, many of you will relate to this, and this has been evolving. So up to SQL Server 2019, we had one file as we started with, and it led to this system page contention. These are the pages that track of your allocation pages. And recommendations were things like add multiple files, turn on trace flags 11, 17, and 18, which is basically to use uniform extents and spread your allocation. And then in 2016, we improved the experience in our setup to give the right recommendation on number of files to create for customers when you install a new version of SQL Server. And also we removed the need for the trace flags because we realized that everybody was turning it on anyway, and the system was well tested and performing well with those trace flags. So we just made it an on by default behavior, right?
Yep, but then the story gets interesting.
Yep. So that removed the contention from some of these common pain points. But in 2019, we uncovered some new problems. It's like peeling the onion, right? Once you unblock where your major contention, the next contention shows up. So,
and by the way, Ajay, what that was is people would call us and say, you didn't fix it. Like, those pages show up, but the pages would be different page numbers.
Different pages, yes. Because end of day, from an application perspective, it'll still show as a TempDB performance issue.
Yeah.
So now when we look deeper into this, system pages became the hotspot for system tables. For example, there's sys, SCH, OBJS.
Yeah, which of course you all know and use all the time.
This is like internal sys objects representation. Yeah. So anytime you create and drop temp tables, we have to go insert and delete rows from that table because it's another object we're adding or removing. So if you have a very heavily used temp table with multiple stored procedures dropping and creating tables, this becomes a hotspot, right?
Yeah.
So what we did in 2019 was introduce what's called TempDB metadata optimization. So this basically leverages yet another cool feature we introduced in SQL Server 2014, codenamed Hackathon or in-memory OLTP, right? So those are latch-free tables in memory. So you have an option to convert, if you see this as a hotspot, your system tables as in-memory tables, thereby getting rid of the latch contention on the system tables. But SGAM and GAM contention still remain, right? Some of those pain points.
Another onion, you're just revealing back another hotspot, right?
The problem keeps shifting, right? So what we did in 2022 is we finally found the reasons why SGAM and GAM concurrency is gone. And latch contention, we're happy to say that we have not seen a single occurrence of latch contention.
I mean, actually, people that are running 2022 and the support team has said they don't get this call anymore.
Correct.
Yeah, I know.
And it's also a peace of mind for you. You don't have to worry about this problem anymore. The system takes care of it for you. And oh, Bob, I didn't know you added this.
I had something. I had another hidden gem. Sorry, Ajay. So you don't want to, by the way, don't do that to your co-presenter. But so here's what happened. This is why this hidden gem thing occurs. So you see that PFS concurrency thing in the middle there, right? And the SGAM pieces. We're going to talk about Purvi's list later, but something named Purvi, which we'll talk about later, she's worked on some of these optimizations because she's this amazing person. So I was talking to Purvi about TempDB I/O, not just latching. I said, Purvi, why can't we do delayed durability on the transaction log for TempDB? She goes, we do. I'm like, what do you mean we do? She goes, we do. We've been doing it forever. You just didn't know about it. So when you actually run transactions in temporary tables, we use delayed durability. And why do we? Because we just recreate TempDB. When we restart, we don't care if the logs records are flushed. It doesn't matter. Because what happens if the system crashes? We recreate TempDB anyways. Well, that's pretty cool. And I said, Purvi, then, is there anything else you've done? Well, yeah, Bob, you know this concept of FUA, where when you have like a disk caching system, SQL needs to make sure when it persists a write to the disk that it is survived by the cache. And we can't lose writes. And I'm like, yeah, we do that. She goes, we don't do it for TempDB. We save I/O. Why do we do that? She goes, well, it doesn't matter, because if the system went down and you brought it back up, TempDB is recreated. So again, a couple hidden gems that you don't have to do anything about is just in the system itself. So yeah, that's why, sorry, I threw that in there.
Yeah,
because it's cool stuff.
Yep, another true hidden gem with all the problems. But we talked a lot about the history and how we got here. We need to see how it works, right? So here we have a demo, and we are going to look at how TempDB worked before. We're going to look at incrementally how we have improved the performance, right? So I'm going to start this demo with, as you can see, one TempDB file and one log file.
Okay, now wait a minute. We're not going to recommend you use one file, but we're going to stress the system by using one file. Okay.
So, so here I'm going to use the defaults, like it's an 8 meg TempDB file and a 200 meg log, right? I'll use all the default settings, auto growth. I'm not changing any of the growth settings or not adding any more files, right? So we also have some new system functions which will help us decode the weights. And
is this your sophisticated scoring system here?
Yeah. So we are going to use the fancy Notepad tool to track the performance of the different scenarios. Yeah. Scenario 1, we are going to test only with the PFS conference I mentioned in 2019. We're going to turn off the 2022 improvements. We're not going to use, in scenario 2, we will turn on the TempDB metadata optimization feature. And then scenario 3, all features. To track the performance, we'll track 2 perf month counters. Let me go back a little bit.
You might want if you use the mouse. Okay, yeah, there you go.
So here we have 2 performance counters. One is a batch request, so that will help us measure the throughput if you're on the TempDB workload. The other one is page latch weights. So this will help us see if there are any latch weights occurring when you're on the workload against TempDB. So let me go ahead and start this back up. So and this is a query we will use. If we get a TempDB latch weight, we can use this query to identify against what page or what object it is. So we are going to disable the optimization using this Ultra Server configuration. We are also going to stop and restart the SQL Server so it takes these new settings. And then now let's go ahead and run. We'll also turn off the 2022 improvements.
Yeah, we got some hidden trace flags.
To do that. Now let's go back and start perfmon, and let's go and kick off our workload with our ostress tool. So we are going to run 25 threads. And as you can see, the green bar represents the batch requests, and the red one represents the latch weights.
It's crazy.
You can see latch weights are over the roof, right? If you look at the number closely, we have waiting on multiple system pages, and you can see it's almost like 100,000 plus latches per second.
It's crazy.
Right? This slows down your system. It eventually completes. Let's go and take a note of how much time it took. It took 19 seconds. Let's record that here in our fancy tool. Now let's go back and run the second test, right? So in the second test, we are going to turn on the TempDB metadata optimization. So this will help us remove any hotspots against system tables like sysobjects, right? So I'll go ahead and disable the 2022 test features with those trace flags. And now I will turn on, let me go ahead and start perfmon again. And I'll go back and run the stress test with 25 threads. Here, now we see that latches have reduced.
Yeah.
But performances also have reduced. Let's see what the weights
is
are.
Worse.
Here we are waiting on page ID 2, which is our GAM page.
Okay.
Right? While we have eliminated the system object contention, we still have one file, and GAM weights take longer. That's why you see fewer throughput, but lesser latch weights, because we have eliminated one contention. But
so longer waits on latches.
Correct.
Yeah.
But we still have one more contention to get.
That's the worst.
Right. So now let's go and see how long this took. This took 28 seconds. It's even longer than the first one. Right?
We made the problem worse, actually.
Yeah. So let's record this again. Now let's go back to the 2022 behavior. So I'm going to clear up all the things I had disabled in the past. Just restart SQL Server 2022 and let it take all the default behavior. And let's see what happens here. So service is stopping and starting. And let's go back and start perfmon again. And rerun the test with 25 threads. Now is it moment to believe and celebrate.
Wait, there's
so
no
we see green.
latch
What
weights.
happened to the red?
No reds.
No red. Let's verify if it's true.
Wow.
Now you can see that there's 0 latch weights with one file.
No latch weights.
And
no
from
latch weights.
100,000
no
latch weights per second to no latch weights.
Come on, man. That's
This is
amazing.
the default
That's
behavior.
good stuff. That's amazing. That's good stuff, man. Ajay, I got to ask you a question, though, as you're finishing it off. So use one data file, but maybe that's just use recommendations still, right?
Correct.
Okay.
Yep. So this is a good test. I mean, but do not try this at home like you hear in the ads.
Well, but
always
I think,
be cautious.
I think just use best practices,
Correct,
right?
correct.
With the multiple files that we've talked about.
The one file still shows you the problem
Yeah.
is gone. So with 8 files, you still don't have to worry, or whatever number of files you use. The default setting in 2022 will help you not have to worry about sleepless nights with TempDB.
But we're trying to just show you what's possible
Correct.
than what we optimized.
Right.
So again, let me summarize if you had to tell somebody what to do. You go to multiple files like best practice, turn on metadata optimization,
Yep.
go to 2022, and your life's easier.
Right.
Is that what you're saying?
Yep. Go and
Okay.
focus on the other problems, right?
Let's see what questions you have
Yeah,
of what we
we'll
talked
take
about so
pause.
far. Anybody got any questions? Can you, if you don't mind standing up and bellowing out your voice? Query abort. The question is it pick up when an application is killed? And the answer to that is no, because that's actually when a session is terminated. So on the server side, that's not a query abort event. So on our side, we don't pick that up as like so there's no packet sent to the server to say, oh, this thing died. We just recognize on the server side that the connection got lost. There is a way to pick that up with the next event, though. There's another event where you can actually determine that. Other questions about TempDB or wait for priority? If you don't mind just bellowing it out. The question is, if you don't have metadata optimization, do you still get the benefits of the GAM, SGAM improvements?
Yes, you will, because the system objects is a different set of pages. The SGAM and GAM are used for allocation tracking. Like anytime you create new objects, SQL Server needs to go and find where the pages, free pages are to create the object. That's what SGAM and GAM are used for. So the improvements we have done will help eliminate those problems.
However, depending on how hard you're hitting the system, if you don't turn that option on, you might see contention on those system tables still, right? And one comment about that, we get this question some, Ajay,
Yeah.
is there were some issues in 19 to start out with.
Correct.
I think we fixed just about every one of them. Like, I can't imagine we're very conservative in SQL Server. We don't do a lot of defaults, quite frankly, like options like that.
Yeah.
So it is a server configuration, requires a restart, but I highly recommend you go test this thing now. I think even all the latest CUs for 19 have them, and then 2022 has those improvements as well. What else? Yeah. The question is that why is what I just said not on by default? That's what I was talking about. The TempDB metadata optimization using in-memory not on by default, because we're conservative people in SQL Server. And we know you are running and powering a lot of SQL servers around the world. So generally, a setting like that, as a server configuration setting, we do not make those defaults. We let you decide what to do. We make you opt in. But we feel comfortable with the fixes we've made that we think people run it in production. Can you, I'm sorry, can you ask your question louder? Does that consume more memory? Talk about how, Ajay, how memory is consumed by this option. How do we consume the memory?
So that's a good question. This is not your user objects, right? If you are using in-memory OLTP for user tables, that can take a lot of space, and usually you have to make sure it can be loaded in memory. These are all system pages. They usually don't take that much space. So while there will be little memory usage, it should not be the same level of usage as other user objects.
Remember, this just is the metadata about your data. So it's very small.
So then what would be the major concern to turn that automatically? Because you say, okay, doesn't use memory.
Great question. The question is like, why just not do it then, right? And that's kind of what we're saying. But we did have some issues out of the gate. Like one issue we found was like customers running certain transactions with TempDB would cause that memory to get larger than expected. Not huge, but larger than expected. But we've resolved just about every one of those things, right? So I feel very comfortable with you trying this in production. But again, we're very conservative. We don't just turn things on by default.
I have one more question.
Yeah.
So so the question, if I repeat, is if the system crashes, how are we preventing corruption from happening? So this goes back to the ACID principles of any database, right? So with TempDB, as Bob shared earlier, TempDB is recreated every time you restart SQL Server. So, which means we don't persist anything to disk.
You mean for in-memory OLTP for the system tables? Yeah, but again, it doesn't matter. Because if the system goes down, we just recreate the thing from scratch. So we don't care about stuff like that. It doesn't matter to your system. Yeah.
The transaction, if it's in the middle of the transaction, the same semantics apply. The transaction is rolled back.
Right.
Or if it's committed, it's executed. So, yeah.
Cool. Another question. Yeah, the question is that, does DB compat affect these gains?
That's a great question. It should not affect these gates. This is not a query plan affecting feature, which is what we use DB compat primarily
Independent
for.
DB compat.
Right? So this
Great
is
question, though.
Yeah. So
Okay, let's talk some availability,
yeah.
Ajay.
So now I'll hand it back to Bob to
Yeah.
cover the next set of hidden gems.
Okay. So we did X event, scalability, availability. So I'm going to talk about the first one in a second. Let's mention a couple of these other three here, these other four. Has anybody used accelerated database recovery before? Anybody used it? Has anybody, you can raise your hand, has anybody not have any idea what the heck that is? Perfect. Somebody walked up to me yesterday and asked about this thing and said, in my workshop, and said, hey, we had this problem where somebody actually had a transaction that they rolled back in the system, and then we were blocked. And then some other DBA said, you know what, I'm just going to crash SQL Server to fix this. What happens? We still got to roll it back. So you have that classic problem where rollback's blocking everybody. Then you try to kill the SPID. It's still got to roll back. That doesn't work. You crash SQL Server. It's got to run through 1%, 2%. Does this sound familiar to you? OK. We had this feature called ADR, Accelerated Database Recovery. We actually shipped it in SQL 19. It is a, again, conservative option for us. It's a database option you turn on. When you do that, we use versioning in your database, not TempDB. So since we're using versioning now in your database, a rollback happens with a snap of your fingers. And the undo part of recovery happens before you can blink an eye. You wouldn't even see it in the error log anymore. So you may be saying, like, why would we not be using this thing? Well, it does take up space because we're keeping versions in your database. And for super write-intensive workloads, there could be a hit because we're actually keeping track of versions. Do you know what the TPCE benchmark is? That's the more modern benchmark we use out there. Negligible. I think it's like 5% or something like that, or less, using this feature. Guess what? We turn this on in the cloud, and you can't turn it off because we need it for your SLAs to achieve it. So we ship it in 19. We noticed some problems. There were some areas of improvement we needed, especially around the area of cleaning up things in versions. Those have all been fixed in 2022. I had a customer that I worked with last year, was talking about these issues, and I went down the enhancement list and said, fixed, 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 fixed. So they're going to turn this on in production now. So I highly recommend taking a look at this. ADR is so beautiful. Here's the thing about ADR that's nice. When ADR is on in an availability group on the secondary, when you do a query, we won't use versions in TempDB. The snapshots, we'll use them in the database. So it could save you space in TempDB and save you time on the failover because the undo portion is very fast. This, again, which is why we put it in the cloud. Parallel redo is an enhancement we made. Oh, yeah, sorry, go ahead. It is, all those enhancements have not been backported, I think.
No, some of them require
it's all just 2022.
some changes.
Nothing's been backported yet, 19. It is versioning only the things that you, if you put on the database, any table that's modified is versioned in that database. It's a database setting. By the way, if you turn it on a given database on a system, but you have other databases that don't have it, you will still see versions of MTB with snapshots. If every database in the system is using this, you would not have versions in MTB. Yeah. This is independent of compatibility. Just saying. OK, another optimization we made in SQL 16 back then was parallel redo. The ability to actually have multiple threads go redo on your database or multiple databases. And one of the limitations was the number of threads that could do this. This is a very handy feature for always-on availability groups because you want to make the redo fast on those secondaries. So what we did is we just enhanced this. We actually have a worker pool now of these redo threads. So it's a very better unlimited feature for you, and it's all just built into the engine. It just comes with SQL to make it work. But we want to make sure you knew about it, because if you're like, hey, I want to see has parallel redo been better now in 2022, it is. And also, if you want to go look at the last valid restore time. When is the last time I can do, or what's the time I can do a point-in-time restore? The MSDB table's been added to go give you that information. This one's interesting. The last one, SQL dumper.
Yep.
Tell us about it, Ajay. You're the one who asked me to put this in here.
Yeah, so this is another hidden gem which we did not know about much later. So this was added in a CU for 2022. So one of the biggest things, especially when you call support, is a lot of times when you have a crash or a hang, you usually are requested to provide a dump, a filtered dump, which itself can cause an outage because it takes several seconds on large memory systems. So one of the things we have done is enhance that to make the dumps run really fast. In some cases, depending on your memory usage at the time, it can be 10 to 15 times faster than normal. So it really minimizes your downtime and increases availability.
So if you have to do a dump within the code on a problem, it's much faster, less intrusive.
Yep.
Or if in CSS is working with you to try to go generate one of
Correct.
these, it can be much faster.
Yep.
Oh, that's nice. It's good to know. Hopefully you don't need that a lot, but when you do, it's good to know it exists. So Ajay, another history lesson.
Yep.
Back in SQL 6.5, we had a bunch of vendors that came to us that are backup vendors, writing backup software. And they knew at the time that we could do backups in SQL to disk. Does anybody know what else you could do a backup to back in SQL 6.5 besides disk? Just a file. Tape. Oh my gosh, does anybody still use tape? Please don't tell me you use tape. Oh gosh, it's crazy. But there's a third one. Does anybody know what it was? A pipe, a named pipe. We had in the code the ability to go stream a backup, take the backup stream and write it to a named pipe. These vendors said, well, that's pretty cool. How can we take advantage of that? We said, well, you can just stream the pipe, but really it's better if we have like a protocol together. Hence was built the virtual device interface back in those days. So we built that for developers, for backup software companies. They would write a VDI program and integrate in a conversation with the backup program in SQL Server to go do the backup, exchange metadata, make sure the backup's done, et cetera. Now, shortly after that time, these vendors said, hey, we work with storage vendors that allow snapshots of the storage itself. And if you don't know what a snapshot is, it's a very, very quick way to get a copy of the files themselves instead of doing a backup stream. They said, well, can you put that in there? So yeah, we said, okay, in the VDI program, we'll put an interface where you can say, I want a backup to a VDI program with snapshot. That's pretty cool because it's super fast to do, super fast to restore. Hence was born SQL Writer. SQL Writer is a VDI program that interacts with volume snapshot servers for Windows to make snapshots possible at the operating system level. Well, this is great, but people had said, especially Linux came along, you could write a VDI program, but I don't have the SQL Writer. How can I do snapshot backups more easily? Hence, cross-platform or T-SQL snapshot backups. Now, I can actually go run a T-SQL command to suspend I/O for SQL Server, perform my snapshot with whatever storage provider I have, and then resume the I/O. Now, why would you want to do this? Well, check this out. I can do backups now of terabyte sizes in seconds, and I can restore them the same speed regardless of size. That's crazy amazing. Quick plug for my friend Anthony Nocentino. We're doing a session tomorrow here at the conference, and Anthony's going to go do a deep dive about how this technology works, especially how it integrates with technology like Pure Storage. So you might find this interesting to go take a look at. Every time I present this to somebody, they're like, well, I'm not doing this. I need to go take a look at it. Now, I'm not saying that you may not need your own streamed backup for disaster recovery purposes. But if you're thinking about your new backup restore window, like how fast can I do now terabytes of backup and restore, this is something to take a look at. A couple of nuggets for you. Number one, the reason we have to suspend the I/O is because the storage providers don't know that we've got exclusive access to our files. Has anybody tried to go on a SQL Server laptop and run Notepad on your database file? You ever tried that? What do you get? Like an error, right? That's because we open the files exclusively at an application level. But at the storage driver level, they don't know that. So we have to suspend our I/O briefly to make sure that they get a consistent snapshot at the lower level of the files themselves. But again, why would I take a small hit on waiting for I/O? Because look at the benefits of this thing. Now, if the support team was here, which I don't think they're here this week, right? I used to be in support. They're going to get mad at me. I got a quick little tip for you. You want to test this? Go on your laptop and start up SQL Server with that trace flag. We will not open the files exclusively. So you can do an X copy on your laptop. So if you want to go test out the procedure of how to do this in a T-SQL language and do your own little snapshot, you can use this trace flag. Warning, 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 not for production use. Do not call CSS, and Bob Ward said to do this. Do not put this on Twitter, that he said to do this. But it is a neat way to test. In fact, we tested ourselves this way.
Yep.
So pretty cool things about availability. But let's go talk about Purvey's list.
Yeah, so when you told me about this, I was really pretty excited, but we need to know who's Purvey and why.
Oh, Yeah, why did I call it that? Oh,
Yeah,
got it.
another storytelling.
Do you remember the PFS thing we talked about and the SCAM GAM thing? You may have people like this in your life, in your company, that are like super humble. Like they're soft-spoken. They hardly say anything. But they're some of the smartest, coolest people in the world. There's a lady named Purvi Shah. She's so humble. It took me like several times to convince her to let me put her name on the slide. She works at Microsoft, the engineering team, and her whole life is to make SQL faster in new and crazy ways. So SQL 19 comes along. Purvi, what's your list? What is stuff that is in there that nobody really knows you did? It could be baked in the engine. It could be something you see, that you see at a surface level. She gave me her list. And I published that in the 19 book and so forth. So 2022 comes along. I email her again. She goes, Bob, I don't want you to put my name out there and stuff. Purvi, just give me the list. So it's an email conversation with her and I. And Ajay, that's the list. And there's some cool stuff on here.
Yeah, let's go through this list. The first one, reduced buffer pool I/O promotions. It sounds very big, but all it does is whenever SQL Server does I/O, we have code in there. I mean, many of you may have heard about read-ahead scans, where we proactively read more pages. And there were scenarios where even if we needed one page, we were reading the whole extent and caused unnecessary I/O. So improvised algorithm to be more efficient on those single-page reads. So we reduce the number of times we promote it to the full extent read. The next one, and again, it's all hidden. It's on by default.
It just works, yeah.
There's no user interface or action needed, and it just works like a charm. The second one is spin lock. Spin lock is used all over the engine code to provide concurrency by locking core data structures. It's one of the algorithms we use. And again, on very high volume workloads, if you run into spin lock contention, it's very hard to resolve those. So we have improved the efficiency of those algorithms to increase the concurrency of your system. So those are the quick insights into those two improvements. We'll spend more time in the second two. How many of you know what VLFs are or virtual log files are? Right.
Everybody.
Yeah, and this was invented many, many years ago, right?
We didn't intend for it to be something anybody worried about, right?
Just like TempDB, this has caused a lot of headache for all of us, right? So we spent Purvi shared some insights on the innovations we have done here to improve the virtual log file algorithms so that we can reduce the number of VLFs we create. The biggest impact of VLFs that you see is the more the number of VLFs, what is the symptom that you see? Anyone? Yes, recovery takes longer because we have to go through every VLF and replay that VLF. So we have improvised the algorithms to create the right number of VLFs and right size so that the recoveries are faster, which means faster availability. But the last one is really cool, instant file initialization. I'm assuming everybody knows this, right? It's also a checkbox and setup now. But there is an issue there, right? Till now, we only supported instant file initialization for data files and not for log files, right? We are not recommending use autogrow. We always recommend customers to right-size their files.
So use autogrow, but don't rely on it. Right?
Autogrow is more like a failback, right? If you run out of space.
Yep.
And you might have a story to tell here, too, with 1105 errors. And
oh, yeah. I mean, all we do is run out of space all the time, right? So autogrow has been just a great feature for all of us, but it's then caused issues with this VLS fragmentation. And because you can't use IFI for the log, it could slow down transactions trying to grow the log, right?
Yep. So what Purvi found out is if you create a log file of a certain size and specify a log growth size of a specific size, Windows presents those files as already zeroed out. So we don't have to intentionally zero out. So which means your log growths are almost instant right now, and you will not have any waits because of that or slowdown of your transactions if there's a lot of log growths happening.
But I want to see it.
Yep, let's go take a look. So the first demo, this is running on SQL Server 2019. So before all these virtual log file and autogrow features, so we can see the 2019 behavior.
This is a recording. I can't change the font. Sorry.
Yep.
You'll see it, though.
You'll have a copy of this, so you can definitely see this. So what you see here is we have a single log file and a single data file, right? You can see I have created a bigger data file, 2 gig, and the log file is small. I intentionally kept it small so we can trigger autogoes. And now in this Next, I have a query. It creates a table, and you can see it inserts a bunch of rows in a loop, and it takes 7 seconds to run. And it's a long character column, so every time the record is inserted, it'll go.
I think you skipped to the second one.
Oh.
You go back, yeah.
Okay.
Go back. Because the first one should take, go to that one. That's the one that takes 17 seconds.
Okay, let's go here. Oops. Okay, let's reset. Okay, so yeah, this is our 2019 instance. Again, one data file and one log file. The log file is only 8 meg, and we'll set up an auto grow of 64 MB, as you can see here, right? So now we will go, let this finish. Now let me switch to the second query window, and I will go run the insert statement. So here our table with column 2 is 7,000 characters. So I'm going to insert 100,000 records in a loop. You can see that it took about 17 seconds to complete. We're also tracking 2 X events, which we have introduced, the wait info external event. This tracks anytime a query is waiting on something outside SQL Server, like mostly likely like OS wait types, like the preemptive OS write file gather. That wait type shows up anytime we are waiting on a growth event, right? Like it calls, that's literally the name of the Windows function we call write file gather. And then we also have tracking the database file size change, which gets triggered anytime the size of the file changes, and we track how long it takes and how much we changed. You can see that it took around 346 milliseconds for 64 meg growth. But if you have many of these numbers become significant, right? Individually, it may look a very small number, but for very latency sensitive applications, this can be significant, and you can see that this query took 17 seconds, right? Now, we also look at the wait types, and you can see the write file gather is the biggest wait type. This is where we are calling the OS to grow, and more than half the time was spent in just growing, like 8 seconds out of your.
So growing the log half the time.
Yeah, 8 of your 17 seconds was just growing the file. So the transaction itself took only 9 seconds, right? And you can also see that we create 51 VLFs, which may not be optimal, right? For this table size, it may be okay, but as more and more transactions come in, this number can just grow, right? Now, let's switch to the 2022 behavior, right? So here, same setup. I have one data file, one log file, same sizes on our auto grow settings, 64 MB growth for the log, 8 MB log file, and 2 gig for the data file. So let's go back and run.
So same thing, same test.
Everything is same.
It's
So we just apples to apples comparison. Yeah. The only thing that changed is the product version. No user configuration required too, other than the setting of running the same batch again, about 150,000 records with large row size. So this is going to dump a lot of transactions in the log, and it will also trigger. We'll trigger the same extended events.
Yeah, I think you went back that one, yeah. Sorry.
So let's go.
Yeah, right, there you go, yeah.
Okay, let's start here.
Right.
Now, if you go look at the extended events, one big thing you'll change is you see the database file size change because we still did the auto grow. It took much smaller time. You can see this, every change was 64 meg. There's the one big thing missing here. It's the wait info external event, which means the OS going and zeroing out the file. So that step was not needed anymore because of the way we are doing auto grows now with IFI. And if we go in 64 meg chunks, which is look at the size change column, and the OS present it as zeroed files. And you can also see in the wait type query that the write file gather no longer shows up as your top wait type. It's actually not there anymore. And the best part is we also improved the number of VLFs. So we have only half the number of VLFs, 26 VLFs. And the last thing I want to show you here is what really matters is how long the query takes to run. And you will see that it took only half the time too, like 17 seconds. So with that, let me hand off to Bob. I'll pause if there are any questions before we go.
We should ask questions on this one, sure.
You will have to set, good question. The question is, do you have to still fix your existing databases to take advantage of this feature? The answer is you have to fix the growth setting, right? It has to be a 64 MB auto growth setting if you are relying on auto grow, right? If you already pre-sized the database and your database never grows, then you're not impacted by this change as much.
As long as you change autogrow to 64 meg or less, it works.
The only thing you have to change is the autogrow setting for your log file, and then
It's independent of DB compat. It's
Yeah.
independent of addition. It's just built in the engine.
yep. The autogrow has to be 64 meg exact.
64 meg or less.
Yes.
That's right. Yeah. So what we found is if we were 64 meg or less, Windows presents it as zeros, and that we don't have to zero the log anymore. But if it's greater than that, then it doesn't work that way. Cool.
Yep. So
Let's
now
finish off with something fun.
Yep. Here you go.
Okay. Good job, Ajay. Again, just to be clear, doesn't matter the addition, doesn't matter DB compat. This is just in the engine. And Purvy told me it's in the cloud too.
Yep.
This is just baked into the engine. Anywhere running, we need IFI for the log, we'll do it. By the way, one thing that you may not saw in there, it's independent of the privilege. You don't have to set the privilege to get this.
Correct.
And it works on TDE because the API calls we make don't require those restrictions. Okay, I know some folks have looked at archiving cold data before. We had this feature we had to deprecate that people have tried to use called stretch. Sorry, don't ask us about that one. That's okay. So I was looking at this thing called the Fabric. Anybody heard of that thing? And I was thinking to myself, how could SQL Server take advantage of that? So many of you use our partitions today, and one thing you do with partitions is you maybe go through the process of switching partitions. And switching allows you to do something like an archive, right? You go take a partition, switch it into another table called an archive table, what do you want to call it? Now, what we have now in SQL 2022 is the ability to do something called CTOS. We can create an external table that exists somewhere else as a select on an existing table. So I can do something like this. I could switch my partition to an archive table. I could create an external table based on the archive table and export the data as Parquet into Azure Storage. So now, when I want to go query this thing, I select from the external table, and it goes and redirects it to Parquet. But to me, it looks like a table. And I could even join it with the existing tables. So I've effectively, in a fairly crude way, archived cold partitions to the cloud in Azure Storage. And I don't really care about these cold partitions being super fast. Actually, it's pretty faster than you think with Parquet, because, again, it's cold data. Well, that's interesting. But I thought to myself, what about the Fabric? Well, the Fabric has an idea called a shortcut. So I can create a shortcut in the Fabric to that Azure Storage Parquet, and now I can go into the Fabric and query my cold data from my partitions without going into SQL itself. And maybe I can do something fun, like I can integrate this data with Parquet with Excel somewhere, and I can be like the guys in the cube and write a Power BI report. I'm not as good as those guys. So I thought I'd like to see some action of what something is possible for you. This works, by the way, in managed instance. I think you saw it today in the keynote. So here's how it works. This is a little bit more of a deeper dive than what you saw. So I've created already here, let me see, make sure this is running. Yeah. I've already created a partition as an example. And in here, I've got a function. You're used to seeing that. It's partitioned by like segments of quarters in my system. And I've got a partition scheme. I've got my table, and I've got my data. So this is just a very simple example of using sales data to archive off maybe colder sales data into Parquet. So going through this process now, I can go create my external data source, which points to Azure Storage. Okay, now, so anytime I reference this data source with like an external table, I know it's going to go into Azure Storage, and I'm going to tell it use Parquet. So this is how simple it works. Let me go switch my partition to my archive table first. I'll do that. And then I can create an external table that queries the archive table. By doing that operation, I've exported the data as Parquet into Azure Storage. Pretty cool, pretty easy. Now, if I want to, I could actually go run a query against that, and it looks like a SQL table, but it really is in Parquet in Azure Storage. Or, of course, I could do something like a join. What about the Fabric part? Okay, whoa. I guess I had this all in one big demo, and I didn't realize it. Yeah, let me go here. Sorry. Right here. Okay, so now that I've got this data as an external table, but it's in Azure Storage, I want to do something with the Fabric. Now, first of all, this is what it looks like in Azure Storage. It's a container with a Parquet file. And we have rules about how many files we create based on the size of the data. I forgot exactly those numbers, but we can kind of segment out these even to multiple Parquet files if we need to. Now, I'm in the Fabric interface. This is a preview of the Fabric interface. They've made some changes recently, but it looks very similar to this. And I'm creating this shortcut which points to Azure Storage. I'm not copying the data into Fabric. I'm just creating like a link, a shortcut into where it exists in Azure Storage. So if I go there and create this name, what I'm going to do is my goal here is to access this data in the native Fabric interfaces, even though it exists as Parquet, which was archived from SQL. So I'll go through this process of doing it. Let me then go create the path. This is my container path. Let me create it. Now, it's in this Lakehouse Explorer interface. By doing this, I can do some interesting things. So first of all, I can go say, hey, here's the Parquet table. And if I want to, I can do some things inside the Fabric itself. So let me go do that. Let me go up here, and I'm going to do what's called a notebook. Maybe you don't use notebooks a lot, but a lot of people that use like this Fabric interfaces love to do Spark. So just because I already have this as a shortcut, I can easily use a notebook inside the Fabric experience to do things like a data frame, which is like querying the data. So I quickly do that, but I don't know where the path is of this thing. The Fabric's going to help me. It says, oh, hey, tell me the path of where this is in Azure Storage. So I'll select that, put in the path, and then go run the notebook. And easily now already I've demonstrated that I've got cold partition data from a SQL Server available to a Fabric user using a Spark notebook inside the Fabric, which is kind of cool, without me having to go export it out of SQL somehow indirectly into the Fabric interface. So let's do something a little bit different. Let's go take maybe the Parquet, though, and put it in what's called a Delta table. And the Fabric interfaces allows you to do that quite easily. So let me go try that. I'll click here and say, hey, put this as a Delta table. Now, the reason I'm doing this is I want to run a Power BI report on this, auto-generated. So I need it in this Delta table format to me get a model in Power BI and to generate a report, because I want to look good like the guy in the Q guys. I want to look really smart like those guys. Well, they're not that smart, but they're really good at Power BI. I know them. That's OK. You can tell them I said that. So it looks like a table to me now, right? No problem. Now, what about that Excel thing I was talking about? This is one of the coolest parts of the Fabric I love. I've got on my laptop this Excel spreadsheet like an analyst would, and I've got something called a one-lake drive. It's like a OneDrive. Now, what it is, though, this one-lake drive on my system can take any file locally, and I can just drag and drop this stuff into the folder. Now, this is sales data that I'm going to compare against my actual data I pulled out. It's like sentiment data. So sentiment data versus sales data. So look how simple this is. I took the file, I dragged it into the OneLake experience, and by doing that on my local laptop now, because it's a OneDrive, it shows up in the Fabric automatically. So that's a pretty easy way just to get files out there inside this Fabric experience. Again, I want to make these things work together. I want a Power BI report that compares sales data with sentiment data. I'll load this as a Delta table. So far, it's not that complicated to do this. But I need a Power BI report out of this. So how do I do it? So now that I've got these both as Delta tables, I can go look at the data itself, or I can say, hey, I'd like a new Power BI data set. In order to do that, I need to go create some modeling against this data itself. I need to say, like, hey, you need to show me the relationships here. So inside the Fabric interface is an easy way to do that. There's an easy way to go look at this data and create what's called a model. This looks familiar to you. It's like relationships between data. I can easily go tell the Fabric, hey, this is customer data I've got in my sentiment. This is my sales data. Here's the relationship between these. The reason I needed to do this is I want to be able to go auto-generate a Power BI report based on what I've got. And I'm thinking, like, is this going to work? But you know what? It's pretty slick. So let's go up here and say I want a new Power BI data set. And as part of that, you have an option to say auto-generate a report. I'll pick the data sets, the tables I've made as Delta tables. And I'll get an interface here option to say, just do it from scratch for me. Just do it automatically without me building it. Now, it generates something that's pretty good, but not quite. So I just adjusted a few columns, and there I go. So now I can go click around on this interface, and I can look at trend analysis. Like, hey, for certain types of sales data, did the product review or the salesperson review affect the sale? Higher, lower, or less? So what did I do? I took a partition in SQL. With a simple command, I exported as Parquet in Azure Storage, which I can still query now as a table. With a shortcut in Fabric, could look at that data. I took my Excel data, put that there in the Fabric, and auto-generated a Power BI report pretty easily. So in your environment now, you could have like an analyst look at your SQL Server archive cold data in the Fabric pretty easily without them to know SQL at all. And that's a possible experience. So what you're going to see from our team in the future is even deeper experiences and deeper integrations between SQL data and the Fabric experience. So pretty cool stuff.
That's pretty cool. It eliminates complex ELT processes.
I mean,
there,
yeah,
so-
I would have had to run a bunch of jobs and I didn't know data factory jobs here. And the thing is, I took advantage of the fact that I can do exports of data to Parquet based on partitions. So look for in the future for us to make this even a better experience. So we covered a lot today. I want to see, before we bring up a resource slide here, to see if you guys any final questions about stuff we covered. Yeah. Can you, I can't. The question is, if you drop the external table, it does not drop the data in, we don't drop the data in Parquet if you drop that table, do you?
I don't think.
I don't know the answer to that
It's
question.
data's already moved.
It's
It
in
just
Parquet. I
breaks
think
the
we just
link.
drop the metadata, and the Parquet would still stay there.
It just breaks your link.
Yeah.
What's the difference between last valid restore time and last log backup?
What's the between
So
last log
there
backup
was a
time?
hidden gem, last valid restore time.
Yeah, the last restore time represents what is the last time you can choose for a point-in-time restore. Like when I want to do a point-in-time restore option, that is the last one I can do.
So I can do a point-in-time restore, but
Based on that dime.
the log is physically not.
Correct.
Correct.
Yeah. Yeah, exactly. Yeah, can you stand up so we can hear it? What's that now? For the external table thing? No, works on all editions.
Yeah, I mean, the documentation covers more details on all the types of formats we support, like Azure Blob Store, S3 storage,
Delta.
Delta Lake,
Yeah.
Azure Data Lake Store, yeah.
So let me stop here and close out, and we'll stay here for final questions. It's so great to see everybody back at the Past Summit again. And I hope we kind of started your day good with a good keynote and a fun little geeky session on hidden gems. Have a great rest of the conference. We'll be here to answer questions afterwards.
Thanks for coming, folks. You want to do a resources slide?
Yeah.